Hi there, future scientists and math wizards. Welcome to Smile Road. I'm Sir M, and I created this channel just for you, senior high school students looking to make science and math easier, clearer, and yes, even more fun. On Smile Road, we explore exciting lessons in general science, solve real-life problems in general mathematics, and learn how these subjects connect to the world around us, from floating boats to your monthly budget. Each meeting, I'll guide you through lessons using simple explanations, real life examples, and even a few challenges to keep your brain sharp. Whether you're reviewing for exams, catching up on class topics, or just curious about how the world works, you're in the right place. Don't forget to hit that like, subscribe, and notification bell so you won't miss any of our learning adventures here on Smile Road. So, are you ready to start this journey with me? Let's walk the road of knowledge with a smile. Our topic for today is about measures of central tendency and dispersion of discrete random variables. This is quarter 3 of grade 11 General Mathematics, Data and Probability, DP. Again, our topic for today is about quarter 3, Data and Probability, lesson Roman numeral number 9, measuring uncertainty, expected value, variance, standard deviation of discrete random variables. Our intended learning outcomes. At the end of this lesson, learners should be able to A. Define the concepts of expected value, variance, and standard deviation for discrete random variables. Letter B. Calculate the expected value, E. A function of x, of a discrete random variable. Letter C. Compute the variance bar of a function of x of a discrete random variable. D. Determine the standard deviation. The standard deviation of x of a discrete random variable. Interpret the meaning of the calculated expected value, variance, and standard deviation in the context of real-world problems. What are discrete random variables? A discrete random variable is a variable that can take on a finite or countably infinite number of values. Think of things you can count, like the number of heads in 3 coin flips, or the number of cars passing a toll booth in an hour. Each value has an associated probability. Expected value, the mean. So the expected value denoted as E, a function of x, or mu, is the average outcome you'd expect if you were to repeat an experiment many times. And it's not necessarily a value the variable can take on, but rather a long run average. Now, to calculate the expected value, you multiply its possible value of the random variable by its probability, and then sum all of these products. So the formula a function of x is equal to the summation of the absolute value of x multiplied by the probability of our x to be a value of x, a small letter x. Let's use an example. A game where you roll a fair six-sided die. If you roll a 1, 2, or 3, you win nothing. If you roll a 4 or 5, you win $5. If you roll a 6, you win $10. Let X be the amount of money you win. So the probability that X equal to 0 is 3 over 6. The probability that X equal to 5, you have 2 over 6. The probability that you will have that x is equal to 10 is equal to 1 over 6. So the expected value, a function of x, is equal to 0 times 3 over 6 plus 5 times 2 over 6 plus 10 times 1 over 6. And the answer is $3.33. Variance. The variance denoted as var of a function of x or sigma squared measures how spread out the values of a random variable are from the expected value. Letter B. A low variance means the values are clustered close to the mean, while a high variance indicates they are more spread out. To calculate the variance, you take the difference between each value and the expected value, square it, multiply it by the probability of the value, and sum the results. The squaring is crucial as it makes all the differences positive and emphasizes larger deviations. So the formula, a variable of a function of x is equals to e times x minus mu squared is equal to absolute value of x minus mu squared times the probability of x is equal to x. Using the same die rolling game example with a function of x equals to mu equal to 3.33. So our variance of x equal to 0 minus 3.33 squared times 3.6 plus 5 minus 3.33 squared times 2 over 6 plus 10 minus 3.33 squared times 1 over 6. The variance of x is equal to 13.9. The variance is a value in squared units, which can be difficult to interpret directly. This is why we use standard deviation. Standard deviation, the standard deviation denoted as sigma is the square root of the variance. It's the most common measure of spread because it's in the same unit as the original data, making it much easier to interpret. It tells us the typical distance a value is from the mean. Formula: sigma is equal to the square root of variance of x. Using variance we just calculated, variance is equals to ay standard deviation is equal to square root of 13.9 is equal to 3.73. In our game, the standard deviation is approximately $3.73. This means that the typical deviation from the expected winning of 3.33 is about $3.73. The relationship between the three is key. Expected value is the center or the average. Variance is the measure of the spread in squared units. Standard deviation is the measure of spread in the original units, making it the most practical and for understanding the data's distribution. The second, intended learning outcomes. At the end of the lesson, the learner should be able to define and explain the concept of expected value, variance, and standard deviation of discrete random variables. Letter B, apply the formulas for expected value, variance, and standard deviation in solving problems involving discrete random variables. Letter C, interpret the meaning of expected value as the long-run average outcome of a random experiment. Letter D, analyze the role of variance and standard deviation in measuring the spread or variability of a probability distribution. Solve real-life problems that involve decision-making using expected value, variance, and standard deviation. Expected value, the mean of a discrete random variable. The expected value denoted by E of x or mu is the weighted average of all possible values that a random variable can take, where the weights are the corresponding probabilities. Letter B, it represents the long-run average outcome if the experiment is repeated many times. Our formula, E of x is equals to mu is equal to summation of x times the probability of x. X is the possible values of the random variable. P, a function of x, is the probability of each value. Example, if a die is rolled, the expected value is E of our x is equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6 over 6 is equal to 3.5. This means that in the long run, the average outcome of rolling a die is 3.5. We will have the next part of our quarter 3 data and probability lesson Roman numeral number 9.